Okay, so now that we know how to simplify, we get to the point where we use radicals as parts of our terms. And this is just part of a number. So you'll see 3x plus 4x, 7x, because x acts as an object, right? You have 3 x's, you add 4 x's, you have 7 x's. It's like apples. Radicals can be used the same way. If you have 5 times root 3 and you add 3 times root 3, you just have 8 times root 3. The root 3 doesn't change, right? You have 5 of them, you add 3 of them, you have 8 of them. So the goal when doing operations with radicals is, can you get the same radical? And if you can add them together. And if you can't, then you're just done. And there's nothing wrong with that. And you need to be able to identify that. But it helps just to see how far you can go. So if we look at here, we got root 27, we got root 12, we got root 8. Do those numbers have perfect square factors? And they do. Root 27 is the same as 9 times 3. Root 12 is the same as root, not that, is the same as root 4 times 3. And root 8 is the same as root 4 times 2. Now you can simplify them, because remember that that's root 9 times root 3 plus root 4 times root 3 minus root 4 times root 2. These simplify to 3 root 3 plus 2 root 3 minus 2 root 2. Now remember, they're objects. I have root 3's, I have root 3's. So you can add those together. So you have 5 root 3's minus 2 root 2. And you can't simplify that any further because root 3 is not the same as root 2, so you're done. You need to know when you can stop or when you have to stop. You're stopping there. Okay, stop there. It's not root 1. The roots don't subtract like that. They're objects, just like the x's were. You couldn't add x's and y's. You can't add roots that are not the same roots. Okay? Now look at the next one. Well, this is, again, we have a perfect square. 9 times 3 times x times y plus 4 times 2 times x times y. Well, what do we have? We got root 9 times root 3xy. Well, I mean, I can't do anything with the xy, right? And then root 4 times root 2xy. So that's 3 root 3xy plus 2 root 2xy. But 3xy and 2xy are not the same thing. You might think, well, I can add those together and get 5xy. No, you can't. They're not the same thing. Okay? 3 times x times y is not the same as 2 times x times y. You are done. This is not the same as this. You're finished. Can't go any further. Don't go any further. You're done. Let's do some more. So, you have the negative, and just beware of the negative, right? You got negative 3 and then root 12. Well, that's root 3 and then root 4 times root 3 plus 4. Now 75, so this is when it's good to know your perfect squares. Well, that's 25 times root 3. So that'll simplify to negative 3 times 2 times root 3 plus 4 times 5 times root 3, which will simplify to negative 6 root 3 plus 20 root 3. And now you have root 3 and root 3, so add them up. 14 root 3. Done. Next one. Be wary if your index changes. So now we have cube roots. So we're looking for perfect cube factors. So this becomes 2 times the cube root of 8 times the cube root of 2 minus 3 times the cube root of 27 times the cube root of 2. Because 27 and 8 are both perfect cubes. So now you have 2 times the cube root of 2 minus 3 times 3 times the cube root of 2. So now in this case, you'll see we have cube root of 2, cube root of 2. So we can actually perform one step further. And we have 4 minus 9, so negative 5 cube root of 2. And you are done. So you'll see how the simplification really works. Knowing perfect squares and perfect cube factors is incredibly helpful. So let's keep going. So now you have root 20. Well, that's square root of 4 times the square root of 5 times the square root of r squared. You'll see why I'm doing that. Times the square root of t. And then minus 2. Remember, I'm looking for perfect squares now, so square root of 9, square root of 5. And now I'm going to say the square root of t squared and the square root of t. Now all I've done is I've broken up t cubed into t squared and t. And I did that because squared and square roots cancel out, and that's my goal. So now you have 2 from here, r from here, and that can't simplify. So I'll keep them together, root 5t minus 2 times 3 from there, t from there, and then nothing. So root 5t. So now what we have is we have 2r root 5t minus 6t root 5t. Now you can't combine those either. And you can't combine those because 2r and 6t can't be subtracted from one another. It wouldn't make sense. You can't say 4r minus t. But what you can do, you can notice that this is a factor, this is a factor, and 6 and 2 have a common factor of 2. So you can actually reverse water bomb, factor out a 2 root 5t, and you're left with r minus 3t on the inside. So, I mean, yeah, it's not beautiful, but hey, it's beautiful in its own way, just like math. Sometimes you gotta look a little bit deeper for that sort of stuff. So now let's look here at one more. So, simplify first. 32. Well, that's root 16 times root 2, and then x, because I know that x is only 1. And actually, at the beginning of the question, you'll see right away, none of the variables have powers, so I'm going to keep them in the radicals the whole time. So plus, perfect square for 48. How about 16? So that's root 16 times root 3y, and then minus root 25 times root 2x, and then plus 9 root 3y. And now you'll see some simplifying happens. 4 root 2x plus 4 root 3y minus 5 root 2x plus 3 root 3y. So now you'll see I have a 2x term and a 2x term, so 4 minus 5, so negative 1 root 2x, and then I have a 3y term and a 3y term, so 7 root 3y. And there's nothing wrong with writing it in that order. Looks great to me. Generally, we put the x's before the y's. And that's as far as we can go. So we are done with that example. And that is the last example. So good luck. Enjoy. Great time.